Welcome to the third lesson in Session 7 on rotations and reflections. A transformation is a general term for four specific ways to manipulate the shape of a point, a line, or a shape. The original shape of the object is called the pre-image, and the final shape and position of the object is called the image under transformation. Four types of transformations we're going to cover is the rotation, the reflection, the translation, and the dilation. Isometry is a transformation in which the pre-image and the actual image are congruent. So a rotation is isometric, a reflection is isometric, and a translation is isometric. So three of the four transformations are isometric. A composition of transformations occurs when two or more transformations are performed on one object. So we start with rotations and reflections. A rotation is a transformation in which an object turns around a fixed point. The center of rotation is the fixed point that an object rotates around. For notation, rotation notation is denoted using a capital R, and the first number that you'll have is the location of the center of rotation, and the second number that you'll have is the degrees that the object is being rotated, and that could be a positive or a negative number anywhere from between 0 and 360 degrees. The center is the center of rotation. So degrees, the number of degrees is an object is being rotated, and a positive number means that we're going to rotate counterclockwise, while a negative number indicates that we'll be rotating clockwise direction. Some examples of common rotations. The first one, we have the rotation of 90-degree rotation about the origin. There's a 180-degree rotation about the origin, a 270-degree rotation about the origin, and lastly we have a negative 90-degree rotation about the origin. Here we have an example. We're going to ask you to perform the indicated rotation. So here we have the coordinate 2, 1 as the red coordinate in the coordinate plane, and we're going to ask to rotate 90 degrees about the origin. So the pre-image is the coordinate 2, 1. So what we're going to do is draw a line segment from the pre-image to the origin. From there we're going to create a 90-degree angle, and we're going to draw this a line of the exact same distance. Where that line segment ends is the actual image, and that image has the coordinate -1, 2. So the general rule for rotation by 90 degrees about the origin is that AB will rotate to coordinate -BA. A 90-degree rotation about the origin is equivalent as a -270-degree rotation about the origin. Next, we'll have a rotation of 180 degrees about the origin. So again, my pre-image represents the coordinate 2, 1. We draw a line segment from the pre-image to the origin, and then 180 degrees continues in that same direction, the same distance. So the blue dot represents the image, which is the coordinate -2, -1. So a general rule for rotation by 180 degrees about the origin is AB will rotate to -A, -B. And a rotation of 180 degrees about the origin is equivalent as a -180-degree rotation about the origin. Next, we're going to perform a rotation of -90 degrees about the origin. So here we have a pre-image of 2, 1. We're going to draw our line segment from the pre-image to the origin, and we're going to draw a 90-degree angle. That's the equivalent distance, and that's going to land on the image, which is the coordinate 1, -2. So a general rule for rotation by 90 degrees about the origin is that coordinate AB will translate to coordinate B, negative A. And a negative 90-degree rotation about the origin is equivalent as a 270-degree rotation about the origin. Next, as we move on, we're going to study reflections. A reflection is a transformation in which an object basically flips over the line. The line of reflection is the line that the object reflects over. And the notation is denoted using a lowercase r, and then in subscript will be the equation of the line that we're going to reflect over. So the rotation, little r subscript x equals a, is a reflection over a vertical line. Rotation of y equals a is a reflection over a horizontal line. In our first example about a reflection, we're going to reflect the pre-image, which is the coordinate 2, 1. We're going to reflect that coordinate over the line x equals 0. Remember, x equals 0 represents the y-axis. So what we need to do is identify the line x equals 0, which lies right on the y-axis. The pre-image lies 2 units from the line of reflection, so we reflect that line exactly 2 units in the opposite side of the line of reflection, which puts us at the coordinate negative 2, 1. So the general rule for a reflection over the line x equals 0 is that coordinate AB will reflect to coordinate negative AB. And next we're going to do the same thing. We're going to do a reflection over the line y equals 0. And the line y equals 0 is the same as the x-axis. So we're going to measure. It's going to be exactly 1 unit from the line of reflection. So we count exactly 1 unit onto the opposite side of the line of reflection, which puts us at the coordinate 2, negative 1. So a general rule for a reflection over the line y equals 0 is that coordinate AB will reflect to coordinate A, negative B. Lastly, we're going to conduct a composition of transformations. And a composition of transformations means we're going to conduct more than one transformations on a single object. For our example here, we're going to reflect across the y-axis of a rotation 90 degrees about the origin of my pre-image. Now, the order in which we conduct these transformations is important. So what I have to do first is rotate. So I am going to reflect the rotation. So the order is important. So the rotation is what we have to perform first so that we can then reflect the rotation. So remember, by general rule from our previous slide, if we're going to rotate 90 degrees about the origin, the coordinate AB will rotate to coordinate negative BA. So coordinate 2, 2 will rotate to negative 2, 2. The point at coordinate 2, 3 will rotate to negative 3, 2, and the coordinate 3, 2 will rotate to negative 2, 3. So my pre-image after the 90-degree rotation about the origin will end up here in quadrant 2. Next, we're going to conduct the reflection about the line y equals 0. So remember, the line equals 0 is equivalent to the x-axis. And the general rule for a reflection over the line y equals 0 is that coordinate AB will translate to coordinate A, negative B. So coordinate negative 2, 2 will reflect to coordinate negative 2, negative 2, and so on. So after our composition of transformation, our image ends up here. So we did a rotation of 90 degrees about the origin, and then a reflection across the line y equals 0. So that wraps up our lesson. Good luck on the quiz, and email us if you have any questions.